Well, hello everyone. We are on page 326 in our text, looking at lesson 23-3, practice. We just learned the law of cosines, coming off the tail end of learning the law of sines, and now we have two incredible ways to solve triangles. So now let's look at item 12. It says, once you know the measure of angle C in item 9, describe two ways to find the measures of the remaining angles of the triangle. So going back to that problem, we found the measure of angle C, which was, I believe, 114 degrees. And so they're asking us, what are two different ways we could find the measure of the other two angles? So initially, we can repeat the exact same process we did to find angle C using another law of cosines to either find the measure of angle A or to find the measure of angle B. Or, in fact, we could also use the law of sines that we learned in lesson 23-1, because now we have an angle and its opposite side, such that we could do sine of C over C. We could therefore find, let's say, the measure of angle A, setting that equal to the sine of A over its opposite side, which we actually do know is 5 kilometers. So what we're getting at here is now that we've learned law of cosines, we can actually use that in connection with the law of sines to solve triangles. So some interesting key components there. So let's actually do that on item 13. It says find each measure round to the nearest tenth. And notice it doesn't say anything about using the law of cosines, using the law of sines. So it's all about solving these triangles based on what's given. So let's take a look at A. So we are not actually asked to solve the triangle. We are simply asked to find the length of QR, which is this side right here. First thing I notice, and I want you to notice, is that we actually have the measure of the angle opposite of that side. Now, although this triangle is not labeled ABC, we can trust that Q could represent A, R could represent B, and S could represent C. So don't get hung up on that. So in fact, I'll even do that. Go ahead and label this A, B, C. And in fact, opposite of angle A, I'll go ahead and label this A. Opposite of angle B, I'll label this B. So when deciding which law of cosines to use, ask yourself, what do you have? Well, we have the measure of angle C, and we have the length of side A and B, and we're asked to find the length of the side opposite of angle C, which again is technically angle S. So we're going to use the law of cosines that's set equal to C. C squared equals A squared plus B squared. I'll go and write out the entire law. A squared plus B squared minus 2AB times the cosine of C. So notice all the elements we actually do have. We have the measure of an angle opposite of the side length we're finding, and we have the length of the other two sides. So that's why I chose this law above the other two. So let's replace some values that we actually know. We know A is 8 and B is 10. So I'll go and replace. C squared equals A is 8, B is 10. 2 times 8 for A times 10 for B times the cosine of the measure of angle C, again, which is technically angle S, but we're calling it C for the sake of the laws written, which is 48 degrees. So now working left to right, doing PEMDAS, we get 8 squared, which is 64, plus 10 squared, which is 100. And then 2 times 8, which is 16. 16 times 10, which is 160, times the cosine of 48 degrees. Now, PEMDAS tells us that we need to multiply first, and that although that is true, but because there is subtraction between these terms and this multiplication here, we can go ahead and combine 64 and 100. That's not going to affect our answer negatively. So C squared is equal to 164 minus 160 times the cosine of 48 degrees. So this is multiplication. Notice I read it as 160 times the cosine of 48 degrees. Since that is going to multiply and give us a decimal with no doubt, I'm actually going to go ahead and key this entire thing into my calculator. 164 minus 160 times the cosine of 48 degrees. So, of course, I'm using the Desmos calculator. I'm going to make sure it's in degree mode. It is. So let's make sure we input it correctly. 164 minus 160 times the cosine of, forgetting the number, 48. And we get 56.9. Now keep in mind that is c squared, 56.9. And in fact, I'm going to go and keep a couple of these other decimals. It's always dangerous to round too much within the problem, so I'm actually going to keep a couple of these decimals. So 56.9391, that looks good. So c squared is equal to 56. And I'm being so forgetful here, 9391, which is obviously not the length of that third side because the length of these other two sides are 8 and 10. So it seems a little too large for this triangle. Not that it couldn't be. So the last step we need to do is take the square root of both sides. So I'm going to go and do that here. So C will approximately be the square root of 56.9391. So we'll do that in our calculator. The square root of 56.9391. And again, rounded to the nearest tenth. So it's 7.5. The first 5 is in the tenths place. So the 4, although there's a 5 right behind it, the 4 tells the tenths place to round down or stay where it is. So the length of the side we're missing is 7.5. So the length of QR, which again we called AB, which we called lowercase c, is 7.5. And there's no units here, so we don't have to worry about writing meters or inches or feet or anything like that. So 13a is an example of how to use the law of cosines to find a missing side. Now let's look at 13b, using the law of cosines to find a missing angle. So I'm going to do the exact same thing over here that I did with the triangle, kind of relabeling QRS with ABC. So DEF is alphabetical order, so I guess I'll do it that way. So I'm going to label that A, B, C. And opposite of angle A, I'm going to label it A. Opposite of angle B, I'm going to label it B. And opposite of angle C, I'm going to label it C. So our goal when they tell us to find the measure of angle D is this angle right here. So when deciding which law to use, if our goal is to find this angle, we definitely have to use the law of the opposite side of that angle. So technically we're going to use the law that is set equal to A, or more appropriately, A squared. So A squared will equal, if you notice, each of these laws, it's set equal to one side length squared, and then it's the other two side lengths squared and added together, minus 2 times those two other side lengths, times the cosine of the measure of the angle opposite of the side length it's set to, so cosine of A. Which again, I understand it is technically angle D here, but just so we're not too confused with using which law. So I'm going to replace it with values I know. So we actually do know the length of A, or the measure of A. So I'm going to replace it with 21. We know the length of B, which is 11. Length of C, which is 19. And I'm going to replace B and C again with 11 and 19. And keep cosine of A, because our goal is to find the measure of angle A. Again, yes, the measure of angle D. So we're going to, again, complete PEMDAS from left to right. So get another color just to change it up a little bit. 21 squared is none other than 441. 11 squared is 121. 19 squared is 361. Minus 2 times 11 is 22. Times 19 is 418. times the cosine of A. Now, just like on the previous problem, we can go ahead and find this sum, even though there is multiplication here. And again, the main reason we could do that is because it's separated by this subtraction. So we have 441 equal to, I was about to write 121 again, but we're actually going to add 121 plus 361 and get 482 minus 418 times the cosine of A. So hopefully at this point we understand that subtraction in this case could also be represented as a negative. So although this is 482 minus 418 times the cosine of A, it can also be viewed as negative 418 times the cosine of A. So our goal right now is to get the negative 418 cosine of A by itself. That's our first goal. So we have this 482 that's causing a problem. Well, that is technically a positive 482 trying to add to this, although I know you see the subtraction sign, it's technically a positive 482. So we're going to subtract 482 from both sides. And yes, we'll get a negative answer over here. So we get negative 41 equal to, of course, this will cancel out. I'll go and show that. Negative 418 times the cosine of A. So now our next step, since this is negative 418 times the cosine of A, our next step is to get the cosine of A by itself. And this is technically a negative 418 times the cosine of A. So to do that, we're going to divide both sides by negative 418. How do you undo multiplication? Well, of course, it's division. So on this this right-hand side, that will cancel or become the number 1. And so we'll be left with, on the right side, the cosine of A equal to, now we probably could simplify this. I'm not going to go into that, although it's not going to affect our answer. But I will at least change that these two negatives dividing, even if I don't know if there's another number besides 1 out there that can divide into both, I do know that 2 negatives, when they divide, will become positive. So it's okay if we write 41 over 418. I will also stress that if you left it as a negative 41 over negative 418, it's not going to cause any issues. This is equivalent to that. So our last step, and the whole goal here was to find the measure of angle A. So recall when we first learned of the trig functions that we use the inverse trig function to find the measure. So if we're using the cosine of A to find the measure of angle A, we're going to use the cosine inverse of this ratio. This is technically a ratio, a fraction, 2 numbers comparing. So we'll do the cosine inverse of 41 over 418. So we'll hop over to our handy dandy graphing calculator and calculate the cosine inverse. Just make sure 41 over 418. 41 divided by 418. I see that I've done just the cosine, so we need to get rid of that. We need to do the cosine inverse of 41 divided by 418. And we get 84.37. Let's see what they want us rounded to the nearest 10. So 84.3, the 7 tells the 3 to round up, so 84.4 degrees. I want to go and show you that if you left the 41 or the 418 or both of them negative, it's not going to affect our answer because it's what's known as an equivalent fraction. So negative 41 divided by negative 418, and we get the same answer. So don't get thrown off by that. But again, it has to be negative for both 41 and 418. So the measure of the angle we were looking for is 84.4 degrees. So this is a great example here of how we can use the law of cosines to find a missing side length or a missing angle measure. So that is the end of lesson 23-3 practice. Don't forget there's always an activity practice at the end of each of these lessons. So if this is still not enough practice for you, don't hesitate to go to the activity 23 practice, which can be found on page 329 and 330. But that's the end of our time together for this practice. Thank you for watching. I hope it helped.